Okay, so heat of reaction is what we're going to talk about, and it's literally how much heat was lost or gained in the reaction. And remember that heat is just a form of energy. Energy can take different forms. So it's just like how much energy did you lose or how much energy did you gain as the reaction went from beginning to end, reactant to product. So that's where we kind of look back to that diagram from yesterday that we learned yesterday. And oops, I didn't mean to move that. And we kind of look at it and say, okay, from where I started at looks like 200, that's 200, to where I ended up. If you want to know like what your profit was in your business, your fundraiser, your lemonade stand, you want to say, okay, how much money did I have in the end? 350. Okay, but wait, I didn't profit 350 because I had already had 200 in the beginning. So the way you figure out like the net change is to take the final minus the initial. Subtract like what money you had to spend to start your business or what was already there. So 350 minus 200. Okay, so your change in heat or energy is 150. So that difference right there, that difference from here to here, that is your heat of reaction or energy of reaction. It's what was the net difference between the beginning and the end. And that's one of their favorite things to ask. And sometimes people have a hard time seeing it because it's not like, I don't know, reactants are here, products are here, that's not so bad. But right here, you're like, what's this arrow pointing to? And you have to kind of, let me pick another color. You have to kind of extend this over and go, oh, okay, that's not very clear. You kind of have to extend this over and go, oh, okay, that the bottom of the line is lining up with the reactants. The top is lining up with the products. This right here, this is the difference between the reactants and the products. Okay. So back down here. So that is our definition of heat of reaction. It is the final heat minus the initial, like that 350 I had at the end minus the 200 I already had in the beginning. All right. So that's going to be their favorite thing to ask. And then their other favorite thing is they're going to ask is that change in energy, was that a gain or a loss? Okay, was that endothermic or exothermic? So if you think about it, endothermic means heat in. So there should have been a gain in heat. So which one shows a gain? If you start here and then end up down there, so we'll call that A. Or B, you start here and in the end, you're up here. Which one shows a gain in energy from the beginning to the end? Which one shows like the energy was absorbed, that I gained it, not that I released it? B, right? So whenever you see a graph shaped like that, where it ends up higher than it started then, that is endothermic. It went up. Energy went in. All right. So that you're going to have to recognize. The other way to recognize endothermic is if you look, where would the energy be in the reaction to show that energy was absorbed? In the reactants or the products? And the answer is the reactants. So again, for something to be endothermic, energy has to be like put in as an ingredient in endothermic, not produced like as a product and released. Okay. So let's just go to endothermic now. So exothermic. So an exothermic reaction is going to be the opposite. Energy exits. Okay, so they're going to say it like releases energy. So if you release energy, you're really like operating at a loss. So which of these pictures shows a loss in energy? One that started up here, happened, and then ended down here. We'll call that A. Or B, where it started down here and ended up a little bit higher than it started. And the right answer for exothermic is this diagram A. Okay, and the reason I can just take a look at this and immediately know it's exothermic is because it started here and it ended lower than it started, so it must have had like a loss in energy, so it must have energy exited. It must have been exothermic. I can also tell because energy is written in the products, which means it was like produced, given off, not like put in as a reactant. All right, so you have to know the difference between endo and exo by the picture and by like this where energy is in the reaction.